Okay, so this is the second part of the slope notes, and we have some special lines on this page. We're on page 20 right now, and you can see that one of these lines is a horizontal line, and one of these lines is a vertical line. And so their slopes end up being something special. So we're going to prove it before we kind of say what the rule is going to be that you can use every time. So you could use the counting method, but it's kind of confusing right now, right? I didn't go up or down at all. I only went left or right. So I'm going to take these values for x1, y1, and x2, y2, and I'm going to plug them into the formula. They've started for us. They did y2, so minus y1 is 5. See, they're both 5. That's because there wasn't a change in the rise. And then the run ends up being 4, and it should be negative 4. They made a little mistake there. Negative 4 minus 2. So 5 minus 5 is 0. And on the bottom, I have negative 6. And 0 divided by anything is 0. So this line is horizontal, so the slope is 0. Okay, and guess what? All horizontal lines have a slope of 0 because what's going to happen in the rise? Every time it's going to be 0. So from now on, if you ever see a picture of a horizontal line, you can just say slope is 0. Slope is 0. And you're going to watch Slope Dude in a little bit. He's going to tell you that this line is 0 fun. So that will be another way to help you remember. Okay, so now let's look at this line. This is a vertical line. We're going to plug it into our formula for slope. So it's y2 minus y1. So it's 3 minus negative 2, or 3 plus 2, and that's a 5 on top. And on the bottom, it becomes 4 minus 4. So I have 5 over 0. And we know that a number divided by 0 is, and I know you didn't just say 0, you said what? Undefined. Okay? So all vertical lines have an undefined slope. So if you see a picture from now on and it's a vertical line, undefined slope. And Slope Dude's going to tell you something fun about that to help remember. Okay, so looking at 3 or 4 down there, can you remember which one's going to be vertical and which one's going to be horizontal? So go ahead, pause the video. If you can't remember which one's vertical and which one's horizontal, you could graph it out, or you can use the formula for slope, and then come back and see how you did. Okay, so here are my 2 answers. So this first guy, he ends up being what kind of line? He's a vertical line, so his slope is undefined. Okay, it was 5 over 0, so it's undefined. And it says classify the line by its slope, so undefined vertical line, we would say. This guy, this was a horizontal line, and its slope is 0. All right, so the last thing we need to do in these notes is to go back and discuss the rate of change. So that was the one definition that we skipped on the first page, which was page 18. So the rate of change compares the change in one quantity to a change in another quantity. Rate of change compares the change in one quantity to the change versus another quantity. Okay, so go ahead and pause the notes if you need to, if I'm going too fast. Otherwise, we're on page 21. And we're going to find the rate of change here in example 3. It says gas prices. The table shows the cost of a gallon of gas for a number of days. Find the rate of change with respect to the time. And this rate of change could be a decimal, could be a fraction, could be anything. A lot of times, though, it's written as a decimal. So the rate of change is one versus another. Well, this is going to be the change in cost versus the change in time. So really, we just have ordered pairs here. x1, y1, x2, y2. There could be an x3, y3 if you wanted here. So they've already started filling in the formula for slope. They did 209 minus $1.99. And then they did 3 minus 1 for the days. Another way you could look at this is how am I changing from one to the other? Well, in the x values, the inputs were going up by 2. In the y values, the outputs were going up by 0.1. So that would be another way to look at this. And I'm going to show you how that affects down here. 209 minus $1.99 is 0.01. See there? That's where I just got that number from. And 3 minus 1 is 2 right here. That's also that number. And now you'll need to use your calculator. 0.1 divided by 2 is 0.05. Well, how does that relate to money? What does that mean in money terms? That's what per day? 0.05. We're not going to say it's $0.05 per day. We're going to say it's 5 cents per day. Okay? So that was the rate of change. It was 5 cents a day. It went up by 5 cents a day. All right, so go ahead right now. Pause the video and go down to number 5. See how you did on that. Okay, so number 5, our answer here. I did not use the formula for slope, but you certainly could have. I used the table, and I knew that my temperature was growing by 5 degrees each day. My time was going up by 2 hours each time, not each day over here for temperature, each hour, for every 2 hours. So it was going up by 5 degrees, time's going up by 2 hours. This is my x, this is my y, input, output. So the delta y over the delta x is 2 over 5, and then you need to change that into something we can understand. So it's 2.5 degrees Fahrenheit per hour. 2.5 degrees Fahrenheit per hour. Okay, so that's the end of this part of the notes, and the next thing you're going to do is you're going to be watching the Slope Dude video, and you are in for a real treat on Slope Dude.